Okay, like I said before, we can use definite integrals to find the volume of the rotated figure if we look at the graph of the function as a series of rectangles. So let's draw that. Let's say there's a rectangle here. Actually, I'm just going to draw one rectangle first to start off with. So we can just ignore that. Okay. So if we look at the rectangle, the width of each rectangle is dx, right? Dx is the change in x. So from this point to this point, there's a change in x. So that would be the width. So the height of each rectangle would be simply just the function, right? Because let's say this was at, I don't know, let's say this is at 2, x equals 2, and then what would the height be of this rectangle? So the function defines that for x equals 2, y has to be 2 squared. So this has to be 4, right? This whole section is 4, because that's 4, right? Okay. So that's just an example. So now we know that the height of each rectangle is x squared, and the width of each rectangle is dx. However, with the disk and washer method, let's start off with the disk method. As the figure gets rotated, this rectangle gets rotated as well. So like if this rectangle goes like 1 revolution, it becomes a disk. So if you look at here, you can visualize this process. See that disk with this being the radius. Yep. And then there you go. Just make that look better. There we go. Yeah, so for each rectangle, it produces a disk when you revolve it. So what a disk essentially is a cylinder. So it would, if you separate it, sorry for my, you can tell I'm the best artist, right? That's the perfect cylinder. So that, what's the volume of a cylinder? Volume of a cylinder is pi r squared times h, right? So it's basically area of the base times the height. It's the height. Base is a circle and height is the height. So as we look at this figure and correspond it to what we've drawn here and what we said about the height of each rectangle and the width of each rectangle, the width of the rectangle now becomes the width of, or the height of the cylinder, right? Because if you look at this portion, how thick with